Example problem 1.2.3, a residential customer requires 2.048 times 10 to the 7th British thermal units of heat energy, or BTU, of heat energy in the month of January for home heating. The local utility will provide him natural gas at a rate of $1.12 per therm or electricity at 6.3 cents per kilowatt hour. Assuming that the gas furnace is 70% efficient in energy conversion and the electric heating element is 100% efficient, you are asked to determine which option is cheaper for that residential customer. So the question here is really asking you to compare the total amount of the two fuel sources used, electricity and natural gas. So again, I'm going to use the given, find, solution, answer method to analyze this problem. So we just want to go through the problem statement and extract the givens. So the first is what is that total energy in BTUs? We can see that that number was 2.048 times 10 to the 7th BTU, or British thermal unit. So that's how much total energy was used throughout January. So then we have these two fuel sources we have to account for, natural gas and electricity, and the prices of those: $1.12 per therm for nat gas and 6.3 cents per kilowatt hour. So nat gas, I'll just summarize that. That's $1.12 per therm, and it is 70% efficient, which can also be written as 0.70. And then we'll do the same thing for electricity. That was billed at 6.3 cents per kWh, or kilowatt hour. You can see I write it as lowercase k, capital W, lowercase h is kWh. And that's 100% efficient. The electricity conversion is to heat, and so that as a percentage is the number 1. So that summarizes all of the givens that were in the problem statement. So we want to move on to the finds. So what is it that we are required to solve for in this problem? We're looking for which option is cheaper. So we'll just write that down, which option is cheaper. Remind ourselves what we're solving for, and of course that implies that what we're doing is we're calculating total cost when we want to compare those. So we need to know the total cost of natural gas. We also need to know the total cost of electricity. To calculate total cost, however, we need to know the amounts of those two fuel sources that have been used, how much natural gas is combusted and how much electricity is delivered. So the solution method implies amount of gas and amount of electricity. And how we measure the amounts of these two energy sources will be different because of standard conventions related to the industry. We can see that natural gas is, we're going to be calculating the number of therms, and in electricity we're going to be calculating the number of kilowatt hours, both of which are different energy units. A therm is an energy unit and a kilowatt hour is an energy unit. So now we're going to move on to the solution step. So we need to go ahead and calculate the things that we asked for in the required statement. So the solution is going to be involving the 2.048 times 10 to the 7th BTU and the efficiency. So if I divide the total amount of heat energy required by the efficiency of the conversion system, I get the input energy to the system. So energy in is equal to energy out divided by efficiency. So I am needing 2.048 times 10 to the 7th BTUs of heat to be produced. My natural gas furnace is only 70% efficient. That means the input energy is 2.926 times 10 to the 7th BTU. Just pointing out here that you can write times 10 to the 7, or you can write E7. It means the same thing, and both are commonly used in engineering. So you can see we need more natural gas input to the system than heat energy comes out, because it's not a perfect conversion process. For electricity, we take that same required amount of heat energy, 2.048 times 10 to the 7th BTU, we divide by the efficiency of electricity conversion. Electricity converts to heat at 100% efficiency, so we get 2.048 times 10 to the 7th BTU of electric energy required if we were going to power the house with electric baseboard heating, for example. So now what we have to do is figure out how much those two options cost, because we know the total BTUs of natural gas energy required and we know the total BTUs of electric energy required, but that's not what our pricing information was given in. So instead what we need to do is convert over. There's a couple ways to do this. In this problem, what I'm going to do is I'm going to convert from BTU into the unit of pricing. So here I am converting from BTU over into therms. The conversion unit that I'm going to use is to convert from BTU to joules, and then from joules to therm. You don't have to do this multi-part process, but I wanted to demonstrate how different conversion steps work. So to do that, we use a technique called dimensional analysis. So you can see what I'm doing here is 2.926 times 10 to the 7th BTU was my original unit. To go from BTUs to joules, I multiply by joules per BTU. The point there is that the units cancel. And then to go from joules to therms, I divide by 105.5 times 10 to the 6 joules per therm. Gives me a final answer of 292.6 therms of natural gas are required. So now what I'm going to do is calculate the number of kWh that is required in electricity. So again, I'm going to use a conversion process where I multiply the 2.048 e to the 7th BTUs of electric energy required. I'm going to convert that over into joules by multiplying by 1055 joules per BTU. And then I'm going to convert from joules to kilowatt hours by multiplying by 1 kilowatt hour per 3.6 times 10 to the 6 joules. So you can follow through that and you can see how all the units cancel. And so that gives us 6,001.8 kilowatt hours as compared to 292.6 therm. So we have our total energies in the base units of billing. So now what I need to do is calculate the actual cost of the provided energy. So I just multiply the amount of energy, or the quantity of energy, by the unit cost from the energy provider, our utility company. So that was $1.12 per therm for nat gas, which gives us a billed cost of $327.68. And I need to multiply my 6,001.8 kilowatt hours by the rate of 6.3 cents per kilowatt hour. And you get a value of $378.11 if you wanted to heat the room or house, whatever, using electricity. So despite the fact that the electric baseboard heating is more efficient in energy conversion from electricity to heat, it's actually cheaper to convert the natural gas using a furnace. So hopefully that shows you how to convert units and how to include pricing information in the costs of energy. What I want to do next is discuss the results. It's always a good idea to look back at your calculations and do they make sense. Is there any information that can help us analyze whether or not this is a reasonable outcome? And we got similar prices, $327.68 and $378.11. And so that's a pretty good amount of information to say, yeah, that's probably reasonable. We could do some back calculations if we wanted to, but I'm pretty happy with that. It seems like a reasonable amount for a utility bill, and they're very similar. So there is reasonableness to this answer, and that's what we mean a lot of times when discussion or review of our results.